And we're back. It's COMP392. It's week 12 of our winter 2016 semester, and it is part one. We're not going to do too much today. I wanted to go over the fixes from last week's stuff that we couldn't get working 100%, and I want to explain some of them. I've got this lesson. I'm starting off from lesson 11 last week, which is up on the GitHub for Centennial College. So I'm going to be talking about this. I want to briefly talk about particle systems today, show you a small example, and then see if we can use something more interesting for Wednesday. That's what I like to try and do. Okay? And then today, most of the time, what I want to do is sit with your groups, whatever groups are here, sit with you and do your marking for the stuff that was due Friday. So remember, Friday we had that first part due. I want to sit with you guys and go over it and kind of give you a mark that you guys can share. I'll kind of put it up live right away, and then you'll have your first marks live, and we'll give you some feedback on all that kind of stuff. We'll talk about it and take a look at your project. So let's take a look at some of the stuff that we had a problem with. Last time we had a problem with the whole moving from scene to scene. And one of the problems that I detected when I was going through it was we had in a previous version, an event listener that we had for the simulation, right? So if I go back up online, and if I look at a previous version of our code, so if I go to GitHub, Centennial College, and look at lesson 11, and if I go back, I've got 7 commits here. If I go back to a previous commit, so let's say, for example, I don't want to look at this one, right? This, but kind of back a couple of times where I added my end scene way back here on March 30th. Let's take a look at this. So one of the things I was changing was not just the references, but we were trying to work out some stuff where when I was looking at my, by the way, this is showing all the changes. I added my start button, move things around. I changed my start button to restart button, and so on. And one of the problems that I had was that inside the scene itself, and let's see if I have a version of my game.ts here that I changed. Here's my play scene. Oh yes, here it is. In my play scene, I had an event listener. Here, this one here. Take a look how it's been removed now. This one. So I had an add event listener inside. After we set gravity, I had an add event listener of this update. And as soon as the scene would update, right, as an example, I would call the simulate function. Well, this is the problem. This is why it stopped working, because the add event listener would bind to my main scene, and every time I went to the new scene, it would always be part of the old scene, and I couldn't readjust. I couldn't rebind the event listener or remove it properly without causing an issue. So the new version doesn't look like this. This new version doesn't even use the event listener at all. What I've done here, and this is the fix to the whole thing, is if you look at the under scenes, if you look at play.ts, and if you skip down, you can see that inside my there's two places that I normally would simulate, right? One is in the init function, right? So if I have or the start function, so here's inside my scene. Just gonna go in here. Now remember, I've broken these things into layers, right? So if I go down into, just gonna get there in a second. Here's my start scene, right? In my start scene, typically I'd have it way at the bottom down here. I'd have a simulate, right? We're gonna see that in a second, right? So all the way down to the bottom, this.simulate. So I put one at the bottom of my start scene, right? And so that kicks off the simulation, right? That's what the problem was. And then inside my update, right? I do one of these. I check to see if my keyboard controls are paused or not, and if they aren't, then I simulate again, and I simulate every frame. As long as I do this and I don't use the add event listener methodology to simulate the physics, I'm good. It'll work from one scene to the other. And that was the only fix that was required. I told you it was very close, right? It wasn't the web worker. I was like, is it the web worker? What did they do in the web worker? So all web worker does is run a process in the background, and then you can send messages from back and forth from your main thread in order for you to get information from the web worker. And it runs in the background all the time, so it doesn't take up processes from your main process. It doesn't take up it doesn't kind of reduce the performance. So that's what I did there. So let me show you the new version. I've actually did a couple of changes, and so I'm not going to go through all the changes because just from a time perspective, I've put it up on GitHub, but I wanted to kind of make more of a complete game, and I want to talk about some stuff that still needs to be done, some stuff that's there, and it's a silly little game that I put together, but you can certainly take a look at it up on GitHub. So I'm going to go to my my terminal here. I'm going to just type gulp, which is going to kick off my game, and this is what it looks like right now. So if I refresh, I got the coin game, right? Here it is. So now notice what I've done is I've got an overlay, right? So instead of my canvas being at the top portion of my screen, I've given it regular CSS, absolute positioning, right? I've made it absolute positioning, it's top left corner of the screen. And what I've done is I've given it a transparency or an opacity of about 50%, something like that. Meanwhile, in the background, I've got my coin mesh that I've made in Blender, right? And I pulled it in. And all I'm doing here, I've set gravity to 0. I focus my camera on the coin, right? And then what's happening is the coin's just, turning like it normally does. So this is kind of, emulating the coin game. If I click on start, I get to my main coin game. I can do the regular things I normally do. And I've got a bit of an enemy who pushes me off the screen, right? And then when I fall off the screen, notice that my death plane is now invisible. I start over again. And the enemy is going to actively try and carry me or push me off the screen. And I'll talk about the code around that in a second. But here it is. Oh, there's the enemy. He's going to try and get me, but I'm going to run away. If the coins fall off the scene as well, it's my coin, and my enemy, when he hits me, is going to make that weird sound. Watch. He's going to try and push me off the scene, right? So there I'm pushed off, right? And so I can't collect as many coins, and I can jump over the enemy. I can do one of those too. But sometimes what happens is, I'll get flipped around, right? Because, I'll flip over on my, my side. Oh, there he is again, right? It won't kill me, but sometimes it'll be something like that, right? Where I'm done. And then basically I've limited control as to what I can do, right? Unless I just kind of die myself or kill myself, right? And here he is. He kind of starts off at the same time I do. We both fall down, and then he tries to get me off before I can get the coins, right? So my idea is that it's kind of more of a more challenge. It's going to continue to follow me around, right? So if you notice, the enemy is going to try and move towards my location, right? I can try and avoid him. The smart thing to do is to play this game is to actually keep the enemy on the screen, right? Because if he falls off the screen, then he's going to launch or, kind of spawn in the same location he always does and come after me, right? There you go. So he's going to push stuff off, right? And then if I wanted to make it more challenging, maybe this will be level 1. Want to make it more challenging, add an enemy, right? Or add some obstacles, add a hole in the middle of the screen, or whatever you want to do. It's another chance to do it. But he's going to come after me, right? Oh, he fell. And when the enemy falls, he'll just respawn. Oh, there he is, right? And he'll still come after me no matter where I am. So how did I accomplish that? How do I make him so that he can follow me everywhere? It's easy to do in Unity, but not so easy to do here. He's coming after me. He missed me. Right, so I made it some, so it's not exactly perfect. Otherwise, it'd be too hard or too easy. He missed me again. But he's going to come right after me again, right? So if I kind of veer out of the way, he's going to kind of, bye-bye. He's going to kind of, he missed me. If I turn around, pretty soon he's going to be back. Oh, there he is. He's probably pushing me already. Oh, there he is. Now, if I let him, if I give up control, eventually what he'll do is he'll come around and he'll push me right off the screen, right? Because that's his job. His job is to push me around, right, until, he can get me going, right? Even if he falls down or whatever, he'll keep trying to do whatever he's going to do, right? He also weighs more than me. He's his mass, he's twice the mass that I am as the player object, right? So he can eventually, as he turns around, right, he'll try and push me the other way. Meanwhile, I can try and continue to do what I want to do. Now, again, it's very simple. The game is not hard in this level, and I'm getting lots of points. But eventually, what's going to happen is the enemy is going to push me off the screen, wherever the enemy happens to be. Right? Oh, there he is. He's pushing me. And then both of us are going to die. Right? When I get reset, there he is. He's ready for me. Right? I can try and jump over him, like I said, but sometimes it won't be good enough. Oh, there he is again. He's already pushing me off, right? So I can kind of squirm away from him. But let's say I die. What happens when I die? So I want it to be make more of a complete death scene, right? So I die, and then it goes to my game over screen, where it kind of goes on forever. how did I do all this stuff? I mean, it's not much different than what we had. The only difference is that, and I can restart the game and I can go on from one screen to the other with the enemy pushing me until I fall off the screen, right? And if I just leave it like this, it'll just push me continuously off until forever. So some good things that that we had to kind of develop here. It'll keep doing it like forever and ever and ever. And wherever I am on the screen, it'll kind of find me and push me off, right? Especially since it gets there faster because it falls a little bit quicker. You see, as this, Okay, one more time, so I can die again. Oh yeah, I'm done already. Okay. All right. So a couple changes, and I want to talk about them. So again, how did I do this piece? This is just an overlay, a canvas overlay. So I still got the canvas. I still got my buttons, my functionality, my buttons, and everything else. And what I'm using here, again, is both the canvas and the WebGL renderer with the physics engine, even now, to generate the coin spinning around, okay? I mean, I didn't have to do this. I could have done it with just simple 3JS, but what the hell? Since I have it ready, let's use what I got. I also can put more than one coin in here. Right now, I only have one. For my start screen, I wanted to give myself some flexibility to see what I was going to do, right? Okay, what other things could I do? Because I wanted to give myself some more interesting stuff. Well, when I go to my second screen, the enemy, how did I generate him? Well, I made him through by just creating a sphere, and I scaled the sphere so that it would have this other shape, right? I would have another shape of the sphere. So the sphere would look almost ovular, like an egg, right? And it would try and push me off. The idea is that it'll push me off. But how does it find me? How does the enemy find me? Because I put some simple AI together to figure out where I am. Yeah. What was that? No. I made it even similar to that. He can see me anywhere I am on the screen to make it easy. But I could have done something more complex like that. But what I have instead, let me just escape here and just reset the game. What I have instead is, let me show you the enemy script. And by the way, this is all up on GitHub, so if you wanted to check it out, you can certainly do that for some of the key points. For me to go and do this with you guys in the short time we have, it would just eat up all of our time, and I don't want that. So I created the enemy. Here's the enemy. And the enemy is just a sphere geometry. With it's very smooth, 32 divisions in both directions, and I scaled the geometry so that it's 1.5 times on the y-axis, so it's a little bit taller, almost like a capsule, but not quite. It's more of an elliptical object. That's what I've kind of put together. I created a material. I made it kind of reddish, right? More reddish than anything else. And what I've done here is I've given it a mass of 2, so it'll definitely push me. No matter what I do, it'll push me over, right? I set the initial position, and this is the same position. It always starts at -10 relative to me. It'll rush me, right? Which is good. I could have made this more random, but found that when I made it random, sometimes it would land on my head, which can be weird, right? So I had to figure that out. What happens if the enemy lands on my head? And I was thinking, should the enemy just kill me when he hit me? I said, no, I wanted to push me off the screen. That might be even a little bit more fun because he's too fast, right? Unless there was a big, like kind of a much bigger plane, and then I could make it so it's a little bit more challenging. He doesn't receive shadows because I don't care about that, but he definitely casts shadows. And the enemy name, I call him enemy just from a collision perspective. So that's all he is from an enemy perspective. No problems there. But one thing I did do was I created a enemy look and move method, right, which is kind of further down. If you want to look for this, here's move and look. It's called enemy move and look. And what it does, it says this. Look at the player. So wherever the player is, take a look at him. So focus the camera. So move the enemy so that he's physically facing the player. His front is facing the player, right? And then what I want to do is I want to do somewhat similar to what I did when it comes to movement. I created a direction, and I set the initial vector to 5 in the Z direction. That's towards the player or forward. If you actually look at the Unity, or if you're a Unity person, look at the Unity library, forward or vector.forward is actually vector 3001, right? So I just put 005. So it's like really much faster movement than a regular one. And then what I did was exactly what I did with the last one. For my player, I apply the quaternion, so I turn him in the direction that he's going, right? And once I've got that direction, instead of it being X or Y or Z, like I do with my keys, it takes the X or Y and Z in combination and moves it in that direction, usually X and Z. It moves in that direction as I apply both forces, you know, when I apply my central force to that. So it'll move towards me in that direction every single time. That's all. This enemy move and look is the method that actually, you know, makes my enemy look at me and follow me. It's almost like plot follow. It'll follow me wherever I am. May not turn too fast right now, but I could make it so that it's even faster than what it is right now. And even, you know, if I was in a much larger playing field and I had more than one enemy coming at me, let's say like, I don't know, 5 of these guys, it'd be pretty scary. Now I could give myself a gun, and I could blow them up and all kinds of other stuff. No time. But the idea here is that, you know, I can have these enemies that are, have some kind of faux AI coming at me. Okay. In my start method, you know, we have our placing and everything else. I add my enemy before my player. That's the way I do it. Now, before I was using my add event listener for collisions for my player only, but now I added some other collisions. I add a collision for the death plane, so that if something falls on the death plane, right, it'll respawn. So if somehow a coin gets pushed off, or the enemy gets pushed off, or I get pushed off, something that happens, it respawns everything, you know, to where the original positions were, or to random positions, right? I also do a couple things here. I set the rotation of the camera, the rotation to 0. So I start doing that. I also set the position up here when I set the player camera to the player itself. And then I call the simulate function. I do that because I mess with the camera across different scenes. If you notice, when I went to my menu scene, here's my menu scene, my camera is actually detached from my player object right now, right? So I'm actually looking at the coin from far away, right? And then when I click start, my camera gets attached to the player object, right? But what I'm doing is actually removing it from the player object and putting it back on the player object, depending on when I'm going from scene to scene, right? And the last scene, what I'm actually doing is I'm randomly generating 20 coins instead of 10, letting them drop, and as soon as they hit the ground plane, they make that bing, 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 bing sound, and they reset. And they keep doing that over and over again to kind of show that the game is over. Actually, that could have been a nice win scene. If I was going to make a win and see all the coins flashing, if it was I don't know if I made enough points, that could have been a pretty good scene for that. But I figured I'd make that the end scene, the game end. So again, things that we've demonstrated with this project here are moving from scene to scene, having an overlay of canvas. By the way, for my second, my main play scene, if I click start here, notice that I have my overlay on top, but if I've actually made it an overlay. So that actually, you can see through the UI, right? So that I can see through. Before it was just a strip at the top, right? So I've kind of changed that. Oh, here he is. It's going to push me off the scene. And then I start over, right? He's going to keep doing that forever and ever unless I stop him, like I try and dip over him. Sometimes I'm too late and he'll push me to the edge. But look at all these nice coins here all in a row. So they'll respawn. They'll keep on respawning forever until either I get killed or, the enemy pushes me off or whatever happens. Or if I fall off by myself. Things to make it even more interesting would have been to make the plane, the ground plane, slightly slanted, to give it a hole. Like I said, if I have to cross from one plane to the other, once they respawn, they don't respawn in the same plane. They respawn in another section. I was going to make a much larger level, which would be easy to do, and then I can connect the two things, but maybe some kind of bridge to go from one level to the other, which is a lot thinner, to make it easier for me to fall off. So to kind of give you some ideas of what to do from a, just in general from a production perspective. So this last scene again, it's just an overlay, and the background is a fizzy JS scene that'll just go on forever. So I've also generated a high score and all that kind of stuff, and it keeps track of what my score is from play to play. Right? That's all it's doing here. So it's doing kind of the same things as I did before. So going back, so that's how the enemy follows me. The enemy follows me by, it just simply looks at me and then takes the direction, the quaternion, which is the rotation, that where it's looking, takes that direction it's looking at me and applies force in that direction. That's all that's happening, right? So then I'm going towards that. And so basically two forces, one across the x-axis, one across the z-axis, until it moves me wherever I am. And it'll keep doing that every frame. So depending on where I am, it'll keep applying that force over and over again, which is a good thing. I made the death plane invisible, and I did that when I generated up here. So if I was to actually go to the death plane, when I created the death plane, here it is. I just had this little line of code here that says, hey, make death plane invisible during play, comment out next 2 lines during debugging. So I comment these 2 lines out, and then you can see the red, right? Notice that it says death plane material is transparent. It's true. You have to set that to true in order for you to make things transparent, right? Or the ability to have transparency, right? You turn it on, the switch. And the next thing is you want to set the opacity to 0 so that you can't see the death plane. If I wanted to give you an idea of what the death plane would look like, with a little bit of opacity, I can put 0.1, so you can see the death plane would be like a, kind of a very, very light red at this point, right? Let's see what it looks like. So you can see when I turn it on. I just turn it off so that way it wasn't so, so crazy. But if you want to turn it on, it becomes almost like this little area here that you can see, right? That's the death plane, right? But I wanted to make it transparent because there's no point seeing this information. It's going to push me off now. Yay, here I am. So depending on what you want, I personally wanted to get rid of it. I didn't want anyone, I don't have to see the death plane. I remember the death plane could also be a place to respawn. I could have multiple death planes that could spawn me in different positions depending on how far along I got on my game, right? So if I got to a certain point, right, in the game. So for now, let's just undo that change and make it 0. So you can, again, I can have multiple from a progress. I can save my progress and it can take me to the next level if I was going to do that. So that's really the death plane changes I made to there. Coin mesh, no real changes there. Again, some difficulty taking it across from Blender. And again, if you want from a performance perspective, one of the things that killed performance for me was taking it, the actual mesh, reading it in from Blender, converting it, and all that stuff takes a lot of cycles. Also, the fact that I have a bump map across my entire plane, my main ground, and because it's not a plane, but actually a very thin rectangular prism, right? It wraps all the way around. That's bad. That actually adds a lot of overhead to my to my game, right? So I mean, I could have reduced that in different ways, right? That's just one thing I could have done. Could have done differently there. Controls are the same. There's nothing that's different here. I'm just trying to look and see what else I did that's a little different. One thing I had to keep track of was the style for my canvas. And if you notice, I have this set up canvas method for each one of my scenes. If you take a look online, one of them is the opacity of the canvas. In this particular case, is 0.5, right? And my positioning is absolute, right? Now, here's the thing. If I have the exact same stuff in here, and I do for the most part between canvases, the only difference is the height. Is a little difference between one canvas and another. In my play canvases, my height's only 10% of the entire screen, whereas in the other canvases, the height is the entire screen for both my menu screen and my end screen, right? Then it's almost like I should have this setup canvas method as part of my superclass, my abstract scene superclass, right? And then what I could have done is just change one of these attributes, just using the regular JavaScript stuff. So it's just a little different. I wanted to show it to you so you see almost like kind of a complete game that has, it's not that difficult right now, but I mean, it's well on its way. If I spent a little bit more time, if I had someone partnering with me at this point, right, like you guys have, I could probably churn out something of a decent level or two within a very short time, right? Again, it's all amount of splitting up the jobs. And that's really about it for this scene. Let me just take a look at my menu scene, what changes I've made there. So in my menu scene, a couple changes here as well. I added a spotlight, like I said. I also changed my, I put the setup canvas in the exact same way. The only difference is the height, like I said. And what I'm doing here is I actually add one coin, but I keep the whole multiple coin potential in there. So if I wanted to make a start screen with a bunch of coins along the top, or make a design for my start screen, so everything's spinning at the same time or something weird, I could do it, right? It's not a big deal. It's just a matter of kind of coming up with another option for my theme, right? I had the coin mesh the exact same way. And one thing I do is, again, I have the coin game, and notice that I spaced out the label coin game to give a space for my coin that would appear in the middle of my scene. So all I do is just space out my text. So the coin would appear in the middle. Problem with this scene, and I have to be honest with you, is some of the resizing needs to be reworked. I just haven't had a chance to do it. Because if I do one of these, watch, kind of changes my coin, so it shifts it off screen, and that's not what I want. I want my resizing to be perfect. So as I resize this, my coin gets resized at the same time. I'm very close to doing that right now. It's just that I have to adjust my resize method, right? So that's one of the problems that I have, right? So there's that. And the game end scene, no, actually this scene itself, it still uses Fizzy.js, but the game end scene is very similar to that. So if I go to the end scene, again, I use the same kind of idea. I set up my canvas, except this time I make the opacity 0.8, right? A little bit higher opacity instead of 0.5, just so that it's, I can see my buttons because I've got my whole background screen going on at the same time. And I also reduced the sound, the volume of my sound for the coins, because I found that they come down, if they come down all together, it kind of compounds the sound of my coins, so it's really, really loud, right? The other thing is I made the coins spawn at, not just in on the random X and Z locations, but also the random Y location. So I say, hey, give me a value between like 1 and 30. So it can spawn really, really high or really low. So I have multiple coins kind of coming down. So it gives me that like coin spilling sound, right? As opposed to all spilling, because I was generating them all at the same level every single time. So it'd be like all the coins would fall and it would go brong, brong, like all together, right? It was just weird. So I added another level of randomness here in order for me to spawn the coins different places. I have my game over label. I have a score label and a high score label, and all I've done is made my score value a global value, so I can say I can compare if my current score is greater than my high score, then my high score would be my current score, and then I display those at the end. Nothing really special here. So again, it's all up there for you to see, and we solved the problem of this mess. Okay, one more little demo. I'm going to put this up later on. I'm probably going to finish this off on Wednesday, right? But what I've done is I've taken one of our older lessons, I think lesson 7 or 8, right? And let me just stop this one for now. And I'm working on, I wanted to make it snow. Hey, so you know what? We had a snow day yesterday. Let's make it snow, right? So how do I do that with particles, right? So I've got this demo that I'm going to put up right now called Particle Demo. So I'm going to bring that up. And again, it's based off of an older project we had going on. Right? So I'm going to bring it up. Here's my particle demo. And one thing I'm going to do here is I'm going to bring it up in terminal for a second. There it is. And I'm going to kind of give it an initialization. So I'll say git init, git add dots, git commit -m, and I'll say initial commit. Again, this is all the stuff that I've kind of put together from before. Now this particle demo is already working, but I promise I kind of do, a little bit of particle effects here this week. So I'm going to do a little bit today and a little bit on Wednesday when we get together. Today I'm going to show you how to make it snow, and then on Wednesday we'll make an explosion with particles if I can. So maybe what happens is when this red enemy hits me, it kind of sparks, kind of sends out sparks, everywhere else when it hits me. So just to kind of create a special effect. So let's make a new repository. I'll call this thing COMP392. We'll call it particle demo. It's all bonus marks. I'm showing you stuff to give you bonus marks, right? I want you to get bonus marks all the time. It's not required. None of this is required. So let's get one of this. Just kind of go into my terminal window here and paste. And as it reflows, and I've put everything up online. So there's my particle demo. It's up online right now under Centennial College COMP392 particle demo. It's up there for you guys to take a look at, so you guys have something to see if you wanted to download that. But for now, let's take a look at what it does. So here's where I am. I'm going to put up my gulp again. And when I put up gulp, of course it's blocked because I'm already running it over here. Let's try that again. Gulp. Right. When I do that, here's the snow, right? So here's what it looks like to make it snowflake. And again, an older demo that I kind of put together with a little bit of rotation, right? And this is not using Fizzy.js right now, but you could. And what I've got is 20,000 particles, right? Running as snow in different, at kind of different locations. And I've actually got a particle ping object that I'm going to use. Let's take a look at the code really quickly to kind of give you an idea of what to do. So first thing you need to do is I kind of have a couple things. You need points, Three.js points, as well as point materials. Those two things is what you need to create a particle matrix, if you will, right? And remember what particles are. Three.js treats them as individual vertices all over the place. So they actually are part of one system, one geometry. Even though they appear to be different piece parts, they're just disconnected vertices all over the place. Think of it like that, right? One thing to note, which is going to really save you in terms of a frame rate and all that kind of stuff. Generate all your particles from the beginning, right? And if you want to show explosions or something like that, or some kind of emission, instead of redoing your particles or generating more particles, just make them all invisible, right? And the reason for this is because once they're there, all the, the vertices are kind of been loaded up already, so you don't have to reload everything. It takes a little bit of time to do that. So that's kind of a trick, that all the books tell you about. Okay, so there's a few variables I need. On line 63 to 67, if you actually look up on GitHub, you'll see these. I have particles, which is a Three.js.geometry type object. So the geometry actually is a container that holds all the vertices together. That's all it is. So I have 20,000 vertices, right? And the container holds all those vertices together. Particle count is just a number, so I can generate how many particles I want. So in this case, 20,000. And then I need a points material, right, which kind of houses what type of material my particles are going to have. You can use any sprite object you want. For example, any kind of 2D object as your particle, right? And sometimes the more interesting the object, the more realistic the particle. If you want to make more of a smoke, then you'd use something like a hazy particle that's kind of a glob, right? And then depending on how you generate the particle, it can appear like smoke. If you want it more like fire, then you'd use kind of a redder particle, or you can even color a particle that's that doesn't have any color at all. So you need a material, and you need something called points. Points is your particle system, and we're going to talk about this. Of course, I'm going to use delta time to generate the particles. I need a clock, like we normally have in some of our later projects. And then down in here, this is where our particle system starts. So there we have particle count 20,000. So I say this is how many particles I'm going to include in my project, right? And then what I do is I say this. I say, let's make a for loop. Here's our for loop. And what I'm going to put in the for loop is an x, y, and z coordinate of each vertex for my particle. So here's my random location of where my particles are all going to appear in my geometry. So think about my geometry as a huge cube, massive cube, right? And it's just going to link everything together. I just think about it as a container, a loose container, an empty object, an empty game object, if you will, right? And the empty game object is going to house all of my loose vertices all over the place, right? Okay, so then I say, well, look, it's each particle then is a vector-3 object with x, y, and z coordinates. So there's my position in space, right? And then what I'm going to do is take my particles, the geometry object, which is a container object, and I'm going to use the push method because vertices is actually an array that belongs to the geometry object, and push each one of these particles, these 20,000 particles, into my my geometry. Okay, cool. So that's my geometry. Remember, there's two parts. I need geometry and I need a material for all Three.js objects, right? So too for this one. So here's my particle material. This is a little different. So my particle material is of type points material, and points material has a few properties. One of them is color. So my particles are all white right now, right? They're all colored white. You can generate the size of your particles here. Right now my size is 2, which means twice the size of a regular my regular image. I point my map, which is my texture map. So I am doing a little bit of texture mapping here to my snowflake image. This is where my snowflake image is, right? Inside my scene. And then you have to use something called additive blending to blend my color with my texture. So that way I can have whatever color of snowflakes I want. We'll generate this in a second. I also am turning transparency on. If I want to, I can make them so that they're not 100% opaque, if that's my choice. Okay, cool. So I've got my particle material. I've got my particle geometry. Here's what this is. And now what I do is I have a particle system. And my particle system is a new points object that has both the particle geometry and the particle material. Then I add the particle system to the scene as normal. Everything as normal. Nothing different here beyond normal. Once you've got this, you can add your particles in any way you want. How do I animate them? So inside my, I have an animate particles function. Here it is, right? And what I'm doing here is I'm saying, hey, take these vertices, right? So for each vertice, right, this, the vertices array, take the vertices array, and go through, loop through the vertices array, right? And what I'm doing is for each vertex, what I'm saying is, you know, move them minus 200. So if, as long as, sorry, this is my check, this is my boundary check. If my vertex y, the y of my particle, so where it is in space, as it moves down, because they're all going to fall, right? When it gets below 200, the 200 point, in terms of numbers, then what I want to do is generate it in a random location again. So reset my particle. Otherwise, my vert y, right, the y location of my particle, I want you to subtract 10 times the delta time. So basically, depending on how often I loop, every frame, I'm subtracting 10 meters or 10 units from my particle so that it'll appear to fall down, right? Now, what you need to do is, because I'm updating it the way I'm doing it, and it's part of a container object called geometry, right? This geometry. I want to use vertices need update. I want to set that to true, just like saying something like, it's like a dirty update kind of thing. And then what this does is it allows each of my vertices inside my geometry container to be updated so they appear to move. So that's how I'm doing it. I'm animating it every round or every frame in order for us to do that. And there it is. So I create my delta time, which is time.delta time. That's what it is here. And inside my update, I'm calling the animate particles system. That's all that's happening. So let's make some changes to the particles, just so, and we'll end this off on this note right here. So I'm not going to keep going too much because I told you I want to spend most of this period sitting down with the teams and going over their work, right? So let's take a look at this. So I've got my my particles, and inside my particle material right now, the particle material is white. Let's make the particle material red, right? So I want to make it red, you know, red snow. So death snow. Someone died, and it's just their flesh. Yeah, I'm joking. I don't know. I'm making it up. All right, and let's make it so that the particles are really big. They're like 5, right, instead of 2, and see what the effect that has. So I'm going to go back to my view, and then you see that I have red snow, and the particles look more like stars, right? You can make this whatever you want. You can make this so that it looks like a star field simulation if you're flying through space or whatever. And you can see that there's some particles that are close up and some particles that are way far away. And depending on the near plane and the far plane from your frustum, right, from your camera, you might be able to see particles that are quite far away, depending on your light source and everything else, right? But for now, the particles are red and they're way over here. I could also make the color varied, right? Instead of making my particles the same color all the time, I could change this so that I make this random, so that my color is a random number, and I can generate this color, of course. Once I declare my particle material, I can go particle material.color is equal to a random color between 0 and 255, as an example. And then it can be a random color instead of a set color like this, if you want to. So you can make it as random or as, you know, I can also start it off as a one color and move it towards another color over time. There's all kinds of stuff that we can do with particle systems. And once you have a particle system in place, then you can create all kinds of interesting effects. In fact, because the particle system is a 3JS object, you could add physics to it. So let's say, for example, each particle could have a collision effect, right? Because if each particle is part of the geometry, then when the particle hits you, the geometry hits you, and therefore there's a collision. And if it's part of the collision, you can take damage from particles like sparks, like I said before. Any questions around particle system? This very simple particle system that I put into place. We're going to add some more complexity later on. Yes? Well, the good thing is, take a look at my, my frame rate. I'm still hovering around the 58 to 60 range, right? This is for my machine, right? And I've got this other object here spinning around. I can make this object spin faster, obviously. And you see that the frame rate's not really affected that much. Why? Because the great thing about the way this particle system has been made is it's just one object. It's one game object that has 20,000 vertices. Hey, let's make it so that it's 100,000 vertices, and let's see the difference in performance. I'm glad you asked that question. Let's see what happens when I add more vertices to the mix, right? So I'm gonna go back, and where it says my my particle count, let's make it 100,000. Let's see if I can break the system. So I'm gonna make 20, so it's instead of 20, we'll say 100,000, right? And it's still gonna be red, just because it's red ring. Right? Let's see what it does now. Right? Again, I've got 60 frames per second on 100,000 particles inside my geometry. Still not really any kind of degradation in speed or performance. Let's make it 1,000,000. Right? 1 billion. Okay, let's make it 1 billion. There we go, 1 billion particles. Right? Let's see how it really affects things now. And you can see how long it takes to load, right? It's taking its sweet time. And the reason why, it's going to calculate these things. And now you can feel the degradation. Now we're about 5 frames per second at 1 billion, right? Which is kind of really weird. Let's tone it down back to 1 million, all right, if you don't mind. Or is that 10 million? I think it was 10 million. I didn't do quite 1 billion, did I? No, I did, that's 10 million. So 10 million, not really great. Or did I do 1 million? I think I did 1 million. That was 1 million, sorry. No, it's 10 million, 10 million. Let's cut it down to 1 million. Let's cut a 0 out of there. And so that's 1 million particles, right? Let's see what happens with that one. So that's not bad. Now you can see some of them are squares. See those squares right now? There's so many of them that you can see the squares because they're not fully transparent. See them? You can see them as they're coming close, but still I'm getting about 60 frames per second for about 1 million particles. It's a lot of rain, right? A lot of snow, right? It's a little unrealistic though, but sometimes, you know, you can make particle systems that are quite complex, just like this, right? What else? Let's try some other stuff. Let's put this back down to something more reasonable, like 50,000, right? So if I go to 50,000 particles, and you can see that it's more difficult to detect the objects. The squares don't come out; they're actually more transparent. Why? Because the system is able to generate that on the fly a lot faster than when I have 1 million of them, or 100,000. Right? So it's not bad. There's still some issues, right? But it's not so bad, and it's fairly performant based on the number of particles that are in the system. Right? Now here's a great thing. These particles are all relative, right? They're all relative to my geometry. So if I want all the particles to spin, right? Because they're all relative and they're all part of my geometry, what if I spin the entire geometry? So instead of that, because my geometry is the particle system, right? So think about that for a second. Right now, the particle system, all I'm doing is I'm moving the vertices in the particle system, but I'm not moving the particle system itself. Particle system stays at 0, 0, 0, right? So what I can do, because the particle system itself, if you see the particle system, right? And just to test it, if I was going to say, does it act like a regular object? If I say particle system, and if I say dot rotation, right? Can I do that? Yes, I can. If that's true, then we have that rotation in place, right? Let's try this out now. So we have our little tower of power, right? And inside of our game loop, we have our tower.rotation.y is the rotation speed. Let's change the whole particle system. So particle system rotation.y plus equals to control.rotation speed from a test perspective, and see how that looks. And you can see that it can look like this, right? You can actually rotate the entire particle system. And again, this is like, again, 50,000 particles that are generated. Right? So that's pretty cool. What do you think? And it'll rotate with the tower. So it'll make it look like, as the tower rotates one way, I can make it to kind of, rotate the entire particle system around while everything's falling, right? Actually gives me a little bit of vertigo when I look at it too much, right? So the idea is, once you have a particle system, you have a box. Think about this virtual box, right? Depending on how far the vertices are spread out, that's your box. Your geometry will grow or will expand to fit. The container will expand to fit each of the vertices, right? So if I want to make a tight little explosion, right? Think about the difference there. I have a tight little explosion with 50,000 particles, right? and I can time them. I can create a timer and everything else. I have an emitter, going back to a particle emitter system, right? Where it emits the particles, and after a short period of time, let's say 300 milliseconds, it'll show the explosion, make a sound, and then the particles will go away, right? And then they're not really going away. What's happening, right? They are being, made invisible. And if I want more than one particle system, for example, if I want 5 explosions on the screen at the same time, I would generate all these particle systems in an array of particle systems. I would pre-generate these particles. So instead of having, like, let's say 50,000 of them, I might have a bunch of them, but only one explosion will go off as I need. All right, I think that's a pretty good demo for now. One more thing before I let you guys go. I told you I'd kind of start with this stuff is, let's say I want to inspect this a little better. There's actually a plugin. Let me just stop the spinning. It's driving me crazy. There's actually a plugin for Chrome that's called the 3JS inspector. Let me take a look at this for a second. So if I was going to look at the inspector, and if I want to turn on the 3JS inspector, here it is right here. It's just a plugin for Chrome. I have to launch it, right? And what this does, if I look at the actual scene itself, I can see anything that I've shared in the scene will come up here in my objects, right? Right now, I'm not really sharing my scene. My scene is fully encapsulated. But if I wanted to, I could see each of my objects here in the scene, right? So this is neat. Let's go back to that other example. And by the way, I have my other example, COMP392 lesson 11 up on Azure, right? So if you wanted to check out how this would work on Azure, let's go to COMP392, and it'll be lesson 11 on Azure, right? So it's I believe it's lesson 11, if I don't remember the actual thing, .azurewebsites.net or something like that. I don't know why it's not picking up Azure. Probably wrong address. Is that? That's probably what I did, yeah. There we go. So if I go there, and if I'm right, here's my coin game. Let's refresh this. I told you I have an issue, right? Here's my coin game up on Azure, right? Now I want to use the inspector to look at my coin game. My coin game has everything labeled and everything exposed. If I'm going to go to the inspector here, and if I want to turn my inspector, here's my 3JS inspector, I want to turn it on, right? Now take a look at what I got here and what control I have. It's like using .GUI, but here in the inspector, right? So here I am. So let's take a look at, I have my spotlight and my coin mesh. And what I can do, if I click on my coin mesh on the right, I can see the geometry. I can change my geometry, my position, everything I want. Let's say I want to move my position in a different place. I can try and notice how it doesn't allow me to do that because I'm using physics, right? And unless I use dirty a position or dirty rotation, it won't allow me to change my location anyway. And from my geometry perspective, right, you can see that I have full control here, like in real time, of my geometry or anything else. How many faces I have. I can, change the order of the material. I can change the color. So I can change the color to more of a green color. There we go. And the emissive, I can make that blue. So I can add a different sheen to it, and so on. This is all in real time. So I can test it here in the browser before I actually go on and do my changes, which is very useful sometimes. And this is how I kind of tested things on the screen. If I go to the new scene here, is my click to play, right? Take a look at all the options I have down here. Here are all my coins, right? And I can also look at things like my player mesh. Here's my player mesh. And in my geometry, I can change the number of faces, my object 3D, how tall he is, my position, my rotation, my scale. Let's make my scale really big for my player. So I can increase my scale here. And you notice as I do that, right, physics fights me. Let's take a look for a second. Here I am. I'm way over here now, right? I messed with it because I've changed my scale and my positioning, right? And I can kind of take a look at my game from this, from a debugging perspective. It's kind of neat, what you can do, right? So I fully encourage you to use this thing. It's 3JS Inspector. You can download and kind of add into your Chrome if you're interested in. I think there might be another plugin for other browsers as well. But it's kind of a very useful inspector that I've used in the past. And I'm going to continue to use it throughout, especially for things like our particle system. I want to see my particles, how many particles I have. As long as I expose them inside my, on the main, in the global space, or expose my scene, I have access to all my particles and what they're called. Right? An example of this would be the spotlight. I want to turn the spotlight off and on. I want to scale it, the visibility of it, and so on. I can do that. Right? So here, I want to turn the visibility off of my spotlight. There it is. Right? I can turn it on. I can turn my coin mesh off and on. One more coin mesh. Right? As I go. So a lot of little controls built into the screen, and I can do that in the browser. Questions about today. So I covered all the fixes we had for a full game, for for the little coin game that we made with our ongoing example from week to week. Right? Covered that. With the whole state machine working. So the menu scene, going back to the play scene and the end scene, with each scene having an overlay of a canvas. And again, you don't have to use a canvas. I'm just using it as one option. You can also use 3D text if you want. You can also use things like web fonts to make your fonts more interesting, as opposed to the built-in fonts that I'm using, the consoles font. Okay, so that's the other thing. I've also covered just the beginning of how to make a particle system. I wanted to talk about it today. And then I want to complete the particle system on Wednesday with a little bit of an explosion, a little sparky explosion. So every time my player gets hit by something, it sparks, right? And that spark is a little, little effects that I want to put into play to make my game more interesting. Maybe we'll even continue with more particle system next week with kind of like a fire, if something is on fire, or even smoke, which you can kind of generate in a very, very simple way. Okay? Any questions around this stuff? Okay, guys, so from now I'm just going to pause this video. Actually, this is the video for today. And I'm going to start sitting with everyone. I'm going to see if I can, in the next hour, I want to see if I can sit with as many people as I can. And so that way I can, kind of generate some marks for everybody. Okay? We'll see you on Wednesday.